Hey guys, let's talk about combining like terms. That is the next skill you need in order to master Math 0300. So, when we talk about combining like terms, the first thing we need to do is talk about what a term is, because you can't put them together if you don't know what you're supposed to be putting together. So, a term is one chunk of an algebraic expression. I know that's not a terribly mathematical definition, but it's what makes the most sense to a lot of people. So, for example, if I gave you 3x squared minus 4x plus 6, this is an algebraic expression because it has a combination of constants and variables. It's got operations in there. So this is an expression. Each of these pieces, so the 3x squared, the minus 4x, and the plus 6. Each of these is a term. Term 1, term 2, and term 3. So these are chunks, and those chunks get created by the mathematical operators that separate them. Notice that each term, though, keeps the sign in front of it. If we were to put a sign in front of the 3x squared, it would be positive. So a term, if we look at just one of these, I'll pull off the 3x squared. And it has some parts. The first thing it has is a coefficient. Coefficient is a really fancy word to say the number in front of the x, or the number in front of any variable. The letter, if there is one, is your variable. And then sometimes your terms will have an exponent. So in order to combine a term with another one, so in order to put them together, they absolutely have to have the same variable or combination of variables and the same exponents on those variables. For example, if I have 4x squared and a 3x and a 5xy and a negative 2x squared, they have to have the same variable. So this one has an x, this one has an xy. Those are not the same variables. So these two cannot be combined. Now, this guy, the 4x squared, and the 3x both have an x, but the 3x doesn't have an exponent. So these two can't be combined. I can't combine the 4x squared with the 5xy because they don't have the same variables. The only two that I can combine would be the 4x squared and the negative 2x squared. I don't care about the coefficient in the front. It doesn't matter. I care about the variable and its exponent. If those match, then I can put the terms together. I'm going to repeat it one more time for the people in the back. They do not have to have, but I'm not going to repeat it with the highlighter, the same coefficient. So let's do some examples. The first one we have is 3x squared plus 4x squared. So we check, do they have the same variables? Well, this one has an x and this one has an x. Do those variables have matching exponents? Well, this x has a squared, this x has a squared. These match, so we are going to combine their coefficients. We're going to do 3 plus 4, and we are going to keep that x squared. It stays the same. Well, 3 plus 4 is 7, and I'm going to stick the x squared on the back because we're not changing it. So now I have 4 terms in our polynomial. I need to see if some things match. The first thing I notice is that I have 2 constants. They don't have any variables, they don't have any exponents. These already match, so I'm going to write them together. Then I see this guy and this guy. I'm going to see if I can put them together. Well, they both have an A. So that's good news. And I can't see it, but this A has an exponent of 1. This A has an exponent of 1. That's even better news because the exponents match. Variables match, exponents match. I need to combine those. Well, when I look at these two, that's just a Desmos thing. 6 minus 1 gives me 5. For these two, I'm going to squeeze a 1 in front of that A, because if there's not a coefficient, it's automatically a 1. Then I'm going to put my line back the way I had it. Now, I am going to pull out their coefficients. So I have a negative 1 plus 5, and I'm going to put the A on the back. Well, negative 1 plus 5 is a plus 4. I need my A, and I bring down my 5. This is the final version of my expression now that I've combined all of the like terms. Now, the biggest question I get asked is, Ms. Graham, how do I know where to start? Jump in, pick a term. So I am going to pick this one. And I'm going to go see if anything matches with it. I have an X and a Y and no exponents. And here's another one that has an X and a Y and no exponents. So I'm going to write them down next to each other. My 5y Doesn't have any friends. He's back there by himself, but that's okay. He's strong. He can do it. Well, if I have -2 of these, right here, -2 of those, and -3 of those, if I put those together, I end up with -5 of those. And I bring down my 5y because I don't have anybody to put him with. So this is the final version when I combine the like terms for that expression. I'm going to jump in. I'm going to pick one to start with. I'm going to start with the 4 because it's in front. I don't have a better reason than that. Notice this is a +4. The only other constant I have is the -6. So I have a +4 and a -6. Then I'm going to look at my next one. The next one, whoops, I guess I have to make it bigger, is a +3x squared. And then I have a +8x squared. The x's match, the exponents match, so they are like terms. Well, I can do 4 minus 6. That's -2. +3 plus 8 is +11. And I put my x squared on there. So you have successfully combined all of the like terms together into -2 plus 11x squared. This last one looks a little bit intimidating because you've got x's and y's and exponents. Don't worry about it. Pick one to start with. I'm going to start here. So I'm looking for an x. Well, this one doesn't have an x, so it's out. The last one has an x. It has a 2 for an exponent. If I go look for a 2 on the exponent on the x, I am sorely disappointed. So that means it doesn't match this one either. That means I can't combine it. So when I rewrite him, I'm going to rewrite it just like it looks. So then I'm going to start over. Well, I'm not really going to start over. I've already dealt with the 3xy. I'm going to move to the next one. -2y. I'm looking for a term that only has a y. That one's got an x. That is not what I wanted. That means that -2y can't combine with anybody else either. So we're going to write down the -2y. We've already established that our last person back here, our 2x squared y, doesn't match anybody. So he stays like he is. I don't know why it's a he. It just happened. Sometimes you can't combine any like terms, and that's okay. Stay tuned for the next video where we jump into solving multi-step equations. I know you're excited.